Okay, let's do the Unit 1 sample test in our 153 Pre-Calc 1 class. The ball is tossed straight up. Its height is given by this equation. And I'm hoping you recognize the 16 that I talked about in class. If it's tossed up and the t squared part has a 16 or a 4.9 in front of it, depending on whether it's done in meters or in feet. And the time is always in seconds when it's either 16 or 4.9, half a 9.8 or half a 32. So the negative 16 is telling us the unit for time is seconds, and the height is in feet. 16 feet is 4.9 meters. So, determine h of 1. That means put 1 in for each of the t's. 1 squared is 1, so we get negative 16 plus 40 plus 10. So that's 50 minus 16, or 34 feet, the units, because it's going to tell us the height. The height is given by this. Now, just for your information, if there's a 40 here in front of a t, that means it was thrown up at 40 feet per second from a height of 10 feet. So this is something that's going to go up and come down. Thrown from 10 feet high above the ground. So the 10 feet here, and shot up with a speed of 40 feet. So it'll get up to a height of 34. You could actually type this into Desmos and just tap there and it'll say 34 feet. Or no, at 1 second. After 1 second, it'll be up here. We don't know how high it's got. Let's see what happens here. At 1.5 seconds, where is it at? So I have to put 1.5 in there. So I'm going to go to my calculator and just type the whole equation in to show you something. I'm going to type in negative 16x squared. I'm going to use x instead of t, plus 40x plus 10. And then I'm going to go, I'm going to graph it. So I'm going to go zoom 6. So that makes it go 0 to 10. And it goes up off my screen. So I need to push window. I need to look higher in the Y. So I'm going to go 100. And I'm going to mark them every 10 instead of every 1 going up. So here it goes up and down, and went up 10, 20, 30 some feet. We had it at 34 at 1 second. So at 1 second, it should have been at 34. Let's check. Second, calculate the value at 1 second. And it says it's at 34 feet. And if I'm in this check the value, I could actually go 1.5 seconds and say, how high is it? And it says 34 again. Or I could do this. I could go second table set and turn the independent variable on ask. Table set's here, second window. And then I can go to table, and it says, okay, where do you want to know? I say 1, it says 34. 1.5, it says 34. Or I could go through and type negative 16 times 1.5 squared plus 40 times 1.5 plus 10, and it'll work out to be 34 feet. So on its way up, it was at 34 feet. At 1 second on its way up, it was at 30 feet. And at 1.5 seconds, it's already on its way down and it's back to 34 feet. This is saying find the time when it's at 20 feet. Well, I can do some guessing here. It'd be two different times it was at 20 feet, but so we might say at 0.8, that's 30 feet. So 0.6 seconds, 28, too high. 0.3 seconds, oh, that's close. 0.25 seconds, too little. 0.27 seconds, getting closer. 0.28 seconds, getting closer. 0.29 seconds, too much. So it's between 0.28 and 0.29, around a quarter second on the way up, and then it's going to be over here later after 1.5 seconds. Now, you can also just go to y equals and say, put in y, when is y 20? When is it at 20? And so then I can graph, and then I find these intersection points. Now, Desmos, if you had done all this on Desmos, you could just tap on the point and it would tell you. On the calculator, you go second, calculate the intersection, and that it's saying, is this the first curve? See the question mark? And the blue one is the first curve. Is that the other curve, second curve? Yes. And then it says guess. Well, the reason it has guess is there's two places, and so I want to be close to one or the other for it to pick that one. Well, I'm close to that one, so I'm just going to press enter, and it says 0.281 seconds. It's at 20 feet. And also, second, calculate the intersection. Is this one of the curves? Yes. Is this the other curve? Now it's doing red. Yes. And my guess, now I need to be over by that place. And then I can be that place. And I can press enter. And it tells me that place is 2.218. So, determine t where the height is 20. The height at some time is 20 feet. And those are the two times that it's 20 feet. And I just explained what that means. It's the height, it's the time. Find the time when the height is 20 feet. Okay? You could also have solved this, just said negative 16t squared plus 40t plus 10 equals 20. Subtract 20 from both sides, and that would make this negative 10. Equals 0, and put it in the quadratic formula, and you would get these two decimals. We'll be talking more about the quadratic formula, so I'm not going to be concerned, but some of you may have tried that, so I just mentioned it. What does this mean in terms of this? H of 1.5 is saying the height at 1.5 seconds minus the height at 1 second. So it's finding out how much the height changed. What is the change in height between, and this is where the time we start at, minus where we ended at. That's how you find the change. Figure out where you ended at minus where you started, you get the change. So means it's saying what is the change in height between 1 second and 1.5 seconds. Now, the answer to that, since they're both 34 at 1 and 1.5, the change in height is 0. The answer to this is 0, but I'm not asking for the answer. I want you to interpret what this means. Okay? That's number 1. Number 2. The red car is the horizontal line. So here's the red car, which looks like it's going 40 miles per hour. The red. And it stays going 40 for all these. What are these? It's time in minutes. So for 20 minutes, 30 minutes, after 1 hour, it's still going 40 and stays going 40. The other one is the speed of the blue car. And since this is 20 and this is 40, this looks like it starts at about 30 miles per hour and ends here is 50. So it ends going less than 50, but more than 40. So it starts slower and then catches up in speed, but does it catch up with the car here? No, it's behind all this time, getting further and further behind since it's going slower than this one, till finally here, they're both going the same speed. So they start at the same place, and the red one's going faster than the other one, but the other one starts going, when it gets to the same speed, they're going to be going at the same speed across. So they're going, the red one starts out faster, and then the other one gets the same speed, and then the blue one starts catching up later. Determine the velocity at 30 minutes of the blue car. So this was the blue. At 30 minutes, I'm going to be estimating, it looks like it's about 20, 30, 35, 36 miles per hour. Something like that. What's the acceleration at 30 of the blue car? The acceleration is the slope, the average rate of change in the speed. So I need to find the slope at 30. Well, this line is the same slope all the way along, so I'm just going to pick some points I know. It goes from 30 to 40, or up 10 miles per hour in 50 minutes. And that's good enough for the acceleration. The change in the speed over the change in time. It's the slope of this line. Okay. Determine the distance. Determine d of 30 for the red car if the distance d stands for the distance. So how far did the red car go in 30 minutes? Well, it is going 40 miles per hour always, and so its distance would depend on how many hours. Well, 30 minutes is 0.5 hours, and the hours cancel, so 0.5 times 40 is 20 miles. It went 20 miles. It goes 40 miles an hour for half an hour, 30 minutes, half an hour, so it goes 20 miles. What does the intersection of the two lines mean? It means that the blue car and the red car are both going the same speed, which happens to be 40 miles per hour, but it is when, and the time looks like 50 minutes, both cars are going the same speed, which was 40 miles per hour. Don't need these parts because I just wanted to know what it means. Okay. All right, we did this activity in class, and I said I was going to ask you to measure. And some of you will complain profusely when I say you are right or wrong. So I'm going from this mark to this mark on the ruler, and some of you are going to count marks. And the marks, the spaces, there's 16 spaces in 1 inch, so each space is a 16th. So there's 4, 8, 12, 16, 21, 22 spaces of size 1/16, or 1 and 6/16 inches, or 1 and 3/8 inches. We could have counted in pairs and got it. 1 pair, 2 pairs, 3 pairs of spaces, 4, 5, 6, 7, 8, 9, 10, 11 spaces. 8/8 plus 3/8, 11/8. So I could have said 11/8 inches also. Remember to count spaces, not marks. We did a class, the paper was 8.5 by 11, like this paper this test is on. But what if it was on 11 by 17? And if we fold it 2 and 3/16 up on each side, so I've got a piece of paper that's 11 inches by 17 inches, and we fold it 2 and 3/16, and 2 and 3/16 here, 2 and 3/16 from the top, 2 and 3/16 from the bottom. What's the length? Most of you will think this is the length, but it'll be in the long direction here. So it's going to be 17 minus 2 and 3/16 minus 2 and 3/16. So it's going to be 17 minus 2 times 2 and 3/16. If you write that, that's right. You can, if you know how to do your fractions well, you can, or you can switch to your calculator and go 17 minus 2 parentheses 2 plus 3 divided by 16 close parenthesis. And we get 12.625. Units. Width. Well, that would be 11. 11 minus 2 and 3/16 and 2 and 3/16. So minus 2 of these 2 and 3/16. So I can go up just go back and change the 17 to 11. And I get 6.625. And if I wanted that in fractions, I can go, if you have a calculator and want to know math, change it to a fraction, enter, and it says 53/8. This is 53/8. And this is something else. We can go back up there and do that if you want. Math, enter, 101/8. And you can change it to mixed number if you want. Anyway, and the height. Well, the height is just how high you folded it up. 2 3/16. And the volume is length times width times height. So I'll just do the decimal one, 12.625 times 6.625 times, now I got two parts here, so I need to put it in parentheses. 2 plus 3 divided by 16 in parentheses. And I get a height of, or I get a volume of a 182.96-ish approximately. And I'm doing inches times inches times inches, which gives me inches cubed, or cubic inches. So now if I change it to making this x that I'm folding up, I'm going to be doing 17 minus 2x. We folded it there. We're just making this be x now. And then we did 11 minus 2x. And then we did x. And that would be a function of the volume for the volume. And now they want me to determine that gives the maximum volume, what x does. And so I'm going to go to my graph, clear things, and I'm going to put in parenthesis 17 minus 2x, 11 minus 2x, times x, length times width times height. If I push graph, I'll see it go up, clear off the screen, and come down. So, and as we talked about in class, it goes up and down. It has an x-intercept here, x-intercept there, and one over there. So the maximum is up off the screen, and I could go back and change my window to go to a higher maximum, like maybe 1,000, and graph it. And I'll see it come up and go down, and it reaches a maximum there, and then it goes into this nonsensical part over here. So I want to know the maximum there, so I can go on Desmos, you can just tap it and it'll find the max. On the calculator, you go to second, calculate the maximum for, and I have to tell it where to look because there's other places that might be high. So I want to look between there by pressing enter and move over to the other side and press enter and come back. And I think the max is somewhere around there. And it says it happens when you cut one, the x would be 2.1778 inches is where I should fold this thing up to have the maximum volume. What is the maximum volume? Oh, well, that's 182.97. 182.97 inches cubed. I was pretty darn close at doing 2 3/16 guess. Okay? Describe how x-intercepts relate to the box. We talked about that. If the x-intercepts are where it crosses the x-axis, and that's 0, and someplace there, and someplace there. Well, x equals 0 has a volume of 0. That's what the x-intercepts are saying. The volume is the vertical height, because we graph the volume as this equation. This equation. When the volume is 0, it happens when x is 0, because you're not folding any sides up, so there's no sides. When x is equal to 1, 2, 3, 4, 5 and a half, the volume is 0. Why? Well, 5 and a half is half of 11, so you folded the paper in half, which means there's no width in the equation. So, no width. So, no volume. And x equal, it looks like 5 and a half, 6, 7, 8 and a half. 8.5 inches. The volume again is 0. The height of the graph is 0. And that's when you fold it 11 inches long, with 11 inches folds to be, if folded in half, is 8.5. So there would be no length in the box. Okay? So in this situation, the only size fold that makes sense is somewhere between 0 and 5 and a half. So I would say the domain is 0 to 5.5 inches. And the range, well, it's going to have a volume somewhere between 0 and the max, 182.97-ish cubic inches. So that's the range interval from the x-axis up. That didn't show very well there. From the x-axis up, that's how high it got to. Remember, we calculated the maximum, and we got 182.87, okay? All right. This is just, do you understand what a graph is doing? And we haven't talked about these yet in class, but I will. The vase is pictured, and I want the height of the water in the glass as time goes by. So time's on the horizontal on each one of these. And this is the height. And I'm trying to match it up here. So here the height is, there's no water, and up here it's completely full. In the vase, and the water's being poured in a constant rate. So if you pour it into a straight up and down vase that's just a circle or rectangle, as time goes by, it's just going to go up at a constant rate, get to the top after some amount of time. How's it going to look on this one? Well, since it's smaller here than here, when you're pouring water, the water will fill this part faster, and then as it gets bigger, it's going to slow down. So it's going to start going up faster and then slow down till it's full. Now this one, it starts kind of small, gets bigger, so it's going to start fast, slow down at around in here, and then for the rest of it, it's going to start speeding up. And for this last part, it's probably going to go pretty straight on that last part. So it's going to go fast, slow down where it's wider, and then speed up where it's skinnier. And this will be steeper than this because this is skinnier than that. So it probably should look a little bit more like, slowing down and then at this height and then speeding up steeper here because it's skinnier than down here. So this is less steep and more steep. Okay? All right. We talked about these in class. Car gets 30 miles per gallon, drives at 50 miles per hour. How do I get the distance from the time? Time would be in hours, distance, velocity in gallons, and time in hours. Well, time, this is miles in hours, so I'm going to do 50 miles per hour. So if I multiply by t in hours, I would get a distance. So I'm going to do 50 t. The time units, hours, will cancel the hours in the 50 miles per hour and give me a distance. How do I get a distance from the gallons? Well, this is miles, 30 miles per gallon. So if I multiply by G in gallons, the gallons will cancel and I'll get miles. So this would be 30 times the number of gallons. 1 gallon, I'll get 30 miles. 2 gallons, I'll get 60 miles. How do I get the gallons from the distance? So gallons and distance. So I need to turn this around, so I'm doing something to D to get the gallons. So simplified, this is D equals 30G. So to get G, I divide by 30. And D divided by 30 gives me the gallons. And here, I have to turn this around, so I'm going to divide by 50, and I get D. The equation has to have D in it because that says that's the variable. And I divide it by 50 to figure out the time. Now the last one, I have to start with T. This equation starts with T, that one starts with G, that one has a D, that one has a D. So I have to start with this one. It's going to be 50T, and that turns into a D. Now, these both take D. Which one's going to return G? This one. So I have to take D and divide it by 30 to get G. And so that's the equation for this one. Okay. Domain. We have a square root. Remember the two things you have to watch out for: division by 0 and square roots of negatives. So I don't want 4 minus x to be negative, less than 0. I want it to be greater than or equal to 0. So if I add 4 to both sides, I get negative x has to be greater than or equal to negative 4. Subtract 4 from both sides. And then divide by negative 1 or multiply by negative 1, and it's going to be x and 4. But multiplying by negative flips the sign, so the domain is from negative infinity up to 4, including 4. Okay? Now, this one, we can never divide by 0, so x cannot be 3. So it's all reals except 3, because 3 minus 3 is 0, or I could say from negative infinity up to 3, not including it, union 3 to infinity. This one, I have a square root and division. So I can't let under the square root, the 2x has to be greater than or equal to 0. So if I divide by 2, that says x has to be greater than or equal to 0. But this also can't be 0. So, and if I put in 0, I get 0. So x cannot equal 0. So it's going to be x is, I can do it in set builder notation, x has to be greater than or equal to greater than 0. Or I can say from 0 to infinity. Now, this one. So if I have to be able to put it into f, well, the only things I can put into f are from negative infinity to 4. And then I have to be able to put it into r. And I can't get 3. Well, what would give me 3 from this? Well, if I put in 4, 4 minus 4 is 0, square root of 0 is 0, and I would get 3. So I can't use 4. So before I could use 4 in f, but then I can't use the answer 0 in r, so I have to throw out the 4 and only can use from negative infinity up to 4, but not including the 4. Now, x squared. X squared can be anything, so I can put anything for x to get it through this, but I have to be able to put it into there. So I have to figure out what kind of numbers can I put in for x that will give me 4 or smaller. Well, I can only use, if you look at x squared, y equals clear x squared, and I'll go zoom 6. And if I want x squared to stay 4 or smaller, then I can only let x go from -2 to 2 so that the x values are, the y values, what I get out of this is less than 4. So I'm going to write, I can only use from minus 2 in set builder notation. Any number between -2 and 2 will give me a number that's 4 or smaller. I'll never get any negatives, but I have to be 4 or smaller, and those would do it. Or I could say -2 to 2. That was a hard one to look at. These last two are hard ones. Okay. So now we're doing what we're doing towards the end here. How do I get, if s is seconds, and so I want a function that gives me hours if I'm given s in seconds. So if I said that there's 10 seconds, how many hours is that? Or if this is 3,600 seconds, how many hours? Well, I got to take the seconds, divided by 60 to make it minutes, and divided by 60 again, or divide by 3,600 to get hours. And if you want to look at that, seconds, I have to get the units to work, I would want to change seconds to hours. I want the seconds to cancel and to have hours. And so to change seconds to hours, 1 hour is 3,600 seconds. So I have to take the seconds divided by 3600 to get answers in hours. Okay, so now they want me to write a function for the distance given seconds. Now they said the distance the car traveled on its the distance the car traveled depends on its velocity determined by the equation. It's this is confusing. It should be velocity times time. That's confusing. That should have changed that. I didn't catch that. The velocity, how fast you're going to how much time you go, and where d is in miles and velocity is in miles per hour. So if I knew I want a function that gives me the distance and after so many seconds, well, the distance is the velocity times time in hours, but I need the time in seconds, so I have to say, well, the hours is determined by h of s. So I've got to figure out, take the seconds, convert it to hours. That's what this would do. And then take that times the velocity to get the distance. And that would give me the distance in seconds. So it could also be written the velocity times the seconds over 3600 would give me the distance, depending on the seconds. Put the seconds here, divided by 3600, that gives me the hours. Hours times the velocity, the time times in hours times the velocity gives me the distance. So that's written wrong. Okay. Next one. Okay. F of x is this. G of x is this. H of x is this, where these are the x's. And K of x is in the graph. And it says, determine G of f of 1. So I got to put 1 into f. 4 times 1 is 4, minus 3 is 1. So this becomes G of 1. So if I put 1 into G, I get 0. This says find H of, this is when you got H plus G of minus 2. That means H at minus 2 plus G at minus 2. So H minus 2, H is 1. And at minus 2, G is 3. So 1 plus 3 is 4. This says find x such that the y height is 3 in k. So in k, the 3, the x is 1. This says put 0 into g. So 0 into g changes to a 1. So this becomes h of f of 1. So if I put 1 into f, I get 4 minus 3, which is 1. So that says h of 1. And if I put 1 into h, I get 2. And f inverse. So we let f, if f is y, and it's equal to 4x minus 3. To find inverse, we swap the y and x, so we get x equals 4y minus 3. And then we solve for y by adding 3 and dividing by 4. And we get y, or f inverse of x, is x plus 3 over 4. G inverse, since G is a table, it's just going to be changing the roles of G and the X that went into it. So it becomes X and G inverse of X, and the inverse is the original X's minus 2 minus 1, 0, 1, 2, and the inverse, the X now becomes what G was, 3, 2, 1, 0, minus 1. And H inverse is just the table reversed on it, except that it would be many to 1, so it doesn't have an inverse, because we can't have 2 going to that and to that, so there's no inverse. Since H is not 1 to 1. And now we got to put 3 into G inverse. 3 in the G inverse is minus 2. So we got to find f of minus 2. G inverse. So we then go 3 and go backwards, not from x to g of x, but from g of x back to x. That's minus 2, and then we got to put that into f. And so that's 4 times minus 2 minus 3. 4 times minus 2 minus 3, so that's minus 8 minus 3, negative 11. To draw an inverse graph, find some nice points, like this one. This graph starts at negative 7, 5. So the inverse of that point would be 5, negative 7. This point kind of does a nice arch to that point, and that's minus 4, 4. So its inverse would be 4 minus 4. Here's another point. It's straight from there to here. This is about a little over minus 2, a little less than minus 2. So it would go to little less than minus 2 and little over minus 2. This point gets put to there. So there was kind of this nice little curve, and then it went straight from there to there, and now this point was 4 minus 4, so we're going to go to minus 4, 4. So it landed almost on top of itself. So this is not a great example of how to do an inverse, but basically you find points on the curve, switch the x and y, and draw the curve that is a reflection over the y equal x line. Notice this graph flips over that line.